John, I think most people would look around here and say this is a pretty bleak place. It's obviously very arid,
Yeah.
and yet you're telling me this is a very special place.
Yeah, we're in the southwest corner of Wyoming. I spent several years up here in graduate school, and we're very close to Fossil Butte National Monument. We just were over there and looked at the fossil fish and plants and insects and all kinds of things that are in the museum there.
Incredible.
And surprising, in this bleak place, you start digging into the rocks, you find all kinds of wonderful, beautiful things, just amazing fossils.
When we were in the museum, we saw this picture of a lush area. It doesn't look anything
Right.
like that at all.
Yeah, you don't see that here today, do
Yeah.
you? It's very dry. There used to be many more birds, plants, mammals, etc. that used to live here in a lake. And I know it doesn't look like a lake as you look out here, but we're standing on the sediments that got laid down in a lake and now have turned into rock.
Yeah, the lake we're talking about filled up this whole basin, which is huge.
Yeah, extends down to the south of us. We're actually in what they call Fossil Basin. There are two other bigger lake basins, Lake Gosayute to the east, and down into Utah there is Lake Uinta. And you know, we're talking lakes that are maybe half the size of some of the Great Lakes.
And yet there are fossils everywhere here. How did that happen? Are all those fossils flood fossils, or are they post-flood fossils?
Some creationists have argued that these are flood fossils simply because we know that catastrophe is necessary to bury something quickly to make a fossil. But I think in this case that we're actually dealing with a lake and with fossils that formed after Noah's flood.
John, when we were at the Hansen Ranch.
Yeah, out in eastern Wyoming.
Yes, yeah, not far from here. Dr. Chadwick allowed us to look at those massive, massive fossil beds there. Can you give us an orientation of what we were seeing there and what we're seeing here?
So, geologists see four main parts to the geological record. And this doesn't matter if you're a conventional geologist or a flood geologist, we'd still agree that these four parts exist. The first part is Precambrian. And usually in Precambrian, we see things like granites and other kinds of crystalline rocks. Sometimes we see sediments. We saw some Precambrian sediments in Grand Canyon. We'll see those in the Uinta Mountains as well. There's Precambrian sediments there, and those are mostly don't have any fossils in them.
Okay.
And then we get into what's called the Paleozoic rocks. Paleozoic means old life. And those are most of the flat-lying strata that we see in Grand Canyon, which you've seen those. And then on top of the Paleozoic, we have another layer called the Mesozoic. And Mesozoic refers to middle life. And the Hansen Ranch, the dinosaur bones at Hansen Ranch over there, are kind of at the top of the Mesozoic. So we have Precambrian, Paleozoic, Mesozoic, and then the layers that we're looking at here, this is the early part of the Cenozoic. Cenozoic means new life, and that would be right at the top of the geologic column. And so we think that Cenozoic rocks in many places around the world, not everywhere, but most of these Cenozoic rocks we think are post-flood rocks.
So relate then the flood to those layers. Where does it fit?
So some of the very latest Precambrian layers may be flood, but generally we think that the boundary between the Precambrian and the Paleozoic marks the beginning of the flood. So we think the Paleozoic are flood rocks, the Mesozoic are flood rocks, and those layers in most places have the characteristics of going across the entire continent. We have many examples like that here in North America. But you get up here in the Cenozoic, the difference is these are very local types of deposits, so they might extend across the part of a state or even a whole state in some cases, but they don't go on forever across the whole continent. And we see the relationship here in Fossil Basin that this is enclosed in a basin and we can see the edges of it. And so that's the characteristic of many of these Cenozoic layers, is that they're very local compared to the very widespread layers that we see in the Paleozoic and Mesozoic.
So the flood, we were dealing with global catastrophe. We've talked about that
Right.
before. The massive, massive forces that, as Peter said, destroyed the earth. But now are we talking about catastrophes that are more regional, more local?
More local. And so what happened after the flood is these mountain ranges came up in various places. Off to the west, we have the Wasatch Range. Down to the south, we have the Uintas. Up to the north, there's a Wind River Range. We have some uplifts further to the east as well. And as all these mountains and uplifts lifted up, they formed this basin in the middle. And I can actually, from where I'm standing, I can see the edge of the basin over there. If you look off over there, again, you can see these white sediments that all of a sudden end over there.
Those white sediments are lake deposits.
And then those are truncated by the darker colored ridge right behind there. And the rocks in that darker colored ridge are actually sitting up like this. And so because the rocks are sitting up like that, that's making part of the basin right there. And so that's the basin edge.
Is that then part of the evidence that you would say that this is post-flood?
That's
because
right.
all of those forces that we've talked about many times that are uplifting those sedimentary layers, but yet these are all very horizontal.
That's right. So after the flood, the mountains were lifted up, and the flood sediments that were laid down, those layers that some of them extend across continents, those things got bent and twisted and contorted like we've seen in Grand Canyon. As the mountains got uplifted, those got contorted. And so underneath of us, underneath of this basin, those sediments are contorted. But these sediments on top, these are horizontal and flat lying. They're not contorted at all. So that means that the tectonic activity had pretty much ceased when this lake basin was filled up. Well, if you have a basin and you have a lot of rainfall and snow melt and stuff like that, the water is going to fill that basin up and you're going to have a lake here.
So we have this basin, it's filled with water. And we obviously then have a lot of life. We saw, I don't know how many different species of just fish and all of that in the museum. So this was a flourishing area
Yeah, it's amazing.
with all kinds of life.
It's over 200 species of plants now, many species of mammals, about 30 different species of fish have been found now. Insects, arthropods, all different kinds of things have been found here. Birds, I think 30 species of birds are known now, thereabouts. We have reptiles, we have bats, we have snakes. Some of the earliest known fossil horses are found right here in this lake basin and along the edges of the lake basin.
John, I think the fossils that we see here in the bottom of this lake appear to be different than the fossils we've been looking at in the layers laid down by the flood. Sure. What's going on there?
Yeah, in the layers below, those layers, of course, some of them extend across the North American continent. And in really none of the layers you see what we would consider a complete ecosystem. However, we get up to these layers in Fossil Basin here, and all of a sudden we can actually envision this complete ecosystem that was here and kind of know what it looked like a lot better than we know, some of those layers that extend across the United States. Those layers have fossils in them that were transported a long, long ways. These layers have fossils in them that lived and died right here.
Which then brings our mind back to this was a regional, local catastrophe.
That's right. Multiple catastrophes, not just one.
Yes, right. Well, I guess the question would be, where did all of this life come from?
So it's interesting. We see things like the bats, the horses, things like maybe even the alligators, and we know the birds. All those things were on the ark. They were air-breathing animals. Many of them lived a lot of their life on the land, and they would have had to be animals that were on the ark. And, the Bible specifically mentions the birds, and we find 30 species of birds here. We find, various kinds of land animals here in these rocks. And something happens that's different from the rocks that we see underneath. We don't see many mammals in those rocks, and all of a sudden we get to these layers, and believe it or not, Del, there are more mammal species known in the rocks of the Green River Formation than are currently living in Wyoming today.
Wow.
So the rocks of the Green River Formation are more diverse with mammals than the mammal diversity in Wyoming today. It's really amazing.
Well, that also brings our thoughts back again to how much of a change has occurred in this area that used to be lush, filled with all kinds of different living creatures, and now it's basically semi-arid. But that sudden arisal in the fossil record of mammals should tell us something.
Yeah. You know, one of the things that we see starting in these Green River sediments and these Cenozoic sediments that are laid down in this area is we begin to see animals that are completely new. In other words, we don't see things like bats down in the layers below this basin.
When you say new, you're talking about new from the standpoint of the fossil layers?
Right, so we don't see things like that fossilized. And, you know, a challenge to the conventional view is, where did the bats come from? The very first bats that we find, the very oldest bats that we find, are right here in this Green River Formation. And yet they have fully formed wings, they look like modern bats, and where in the world did they come from? Where are the transitional forms from the animals that gave rise to bats if the evolutionary model is true? And so one of the strengths we have in the creation model is that, you know, we can explain the sudden appearance of things like bats because we think that those would have been on the ark. And they didn't get fossilized during the flood, as far as we know. You know, we don't find bat fossils. We may someday. But, you know, when we first find the bat fossils, they're in places like this, where they have the potential to become part of the fossil record here.
So the conventional paradigm, you know, that tells us there is this tree of life where everything begins to evolve, one species evolves into some other kinds of things. What we actually see in the fossil record is what some have referred to as a forest.
Yeah.
That all of a sudden, instead of a tree branching up, we have an immediate forest with all of the diversity of animal and plant and fish life. Is that what we're talking about?
I like to think of it as not a forest, but a bunch of little bushes all around, right? But you have all these multiple little sprouts. All the organisms within one bush share, you know, similarities, so it's conceivable that they could have come from a Genesis kind. And so we see all these little bushes out here. We see the bats, we see snakes, we see various kinds of birds, we see different kinds of plants here that we really don't see in the layers down below. And those things are showing up right here all of the sudden. And we don't see the evolutionary roots in large for a lot of these things that are showing up here.
This is the kind of evidence that you would point to that tells us that the Genesis narrative explains to us what we see in the fossil record.
That's right. I think the Genesis flood very nicely explains what we see below Fossil Basin. And then as we think about Noah getting off the ark and the animals getting off the ark and what would happen after the flood, this fossil basin, I think, nicely illustrates what we see happening after the flood.
Sure, and that makes sense to me. I think the question that we would have then is, after the flood has occurred, those tectonic forces have raised up things, we have water in this basin, what are the catastrophes now, local catastrophes, regional catastrophes, that are going to bury these fish and birds and plants? So as we take a look at some of the rocks that are around here, this is really a type of limestone. Technically, we call it a calcimicrite. And what that means is it has these little particles of calcite that formed in the water. Calcite's a type of mineral. And
these little particles would settle down to the bottom of the lake floor, and they would cover anything that's on the bottom of the lake floor. So if there's a fish or a leaf or any other organism that's dead down there, it would cover that up. And it would actually protect it from further decomposition. And we think this stuff was being laid down fairly quickly. And we know that because the fossils generally are in pretty good shape. So it doesn't indicate that a lot of time has passed between when these organisms died and when these things were covered up.
So we're talking about, let's talk about fish for a minute then. We're talking about some situation where we have maybe a massive fish kill like we've seen,
Sure.
Many times in our day. And those fish have then gone to the bottom, but we know, all of us have been talking about this a lot, that those fish will decay quickly or scavengers will eat them.
So in my PhD work, that was actually the topic of my dissertation work. I couldn't have picked a smellier project, right? I took fish and I killed them, and then I watched them decompose. And the reason that I did that is I wanted to understand the fossil fish here in this basin. And so what I found is it didn't really matter how deep the water was, the salinity of the water, the amount of oxygen in the water. I tested all kinds of different variables, fish species, and other things. The thing that happens is fish decompose within days to weeks. And so, these beautiful fish fossils that we see here, if you don't bury them within days to weeks, they're going to completely decompose and scatter. Their scales will be scattered, their bones will be scattered, and you won't find them preserved.
So we have these dead fish that under almost any circumstances we see today are going to decompose, and yet something was happening here.
That's right.
That we don't see today, and they're being covered with this calcium material,
Right.
that kind of helps preserve them. Are there any other forces that are involved in making this place here such a special place?
Something was different about the water chemistry here. Something was different about the water chemistry in that it was precipitating a lot of this calcium carbonate out, which was covering the fish.
Mm-hmm.
But there's also something else that we see in here as well. But these yellowish layers right here, and we can break one of these open, and you can see how it's kind of pink and yellowish.
Yes.
These are volcanic ash beds. And these are volcanoes that probably erupted from up in the Yellowstone area. The ash came all the way down this way. And sometimes you find fossil fish and plants and other things below these volcanic ash beds.
Is that because that volcanic ash would have probably caused plants and animals and fish to die?
I think so. And nonetheless, it deposited a fair amount of material in probably a day.
Uh-huh.
And so, there's evidence here that the sediments in this lake were accumulating really quickly. The conventional idea, if you look at these layers right here, they come apart, and if you slice them, you even see thinner layers in there. The idea is that each one of these layers, in a conventional view, each layer took a year to form. But I don't think that's the case from studying the fish. The fish decompose quickly, and if it took a whole year to make the layer, we wouldn't have the fish be preserved. They rot and decay too fast.
So we're back to the understanding that in order to have a fossil, in order to preserve a fossil, we have to have some sort of a catastrophic event, and it has to be fairly rapid. Is that correct?
That's right.
So the thousands and millions of years to build up these layers just doesn't give us the fossils that we see.
The fossils, to me, are proof that we have rapid sedimentation going on here. If you have slow sedimentation, there's no way there should be any fossils preserved. Some people would argue that, well, maybe the lake didn't have any oxygen in the bottom. But even in conditions without oxygen, there's bacteria that live in those conditions inside the guts of these fish, and a lot of these fish would have rotted and decayed from the inside out, even without oxygen. And so it really doesn't matter the conditions. The only way to get fossils is rapid burial.
Well, this whole basin here is just almost overwhelming to think about not only the catastrophic events that were occurring here, because we have, I don't know how many feet of sediment we have here.
Thousands, yeah.
Is it thousands of
Yeah,
feet?
yeah.
I mean, that is remarkable to me because we don't see that happening today.
That's right. We don't see really today places where you get large accumulations of sediment happening really quick. And it looks like after the flood, there were processes that were going on which were exponentially larger and bigger than the processes that we see going on today.
So that covers all of those catastrophic events that we see today. Earthquakes, volcanoes, floods are just tiny compared to what was happening after the
Little
flood.
glimpses as to what the world may have been like after the flood, I think.
Yeah, yeah. How would you respond to someone who would say, well, wait a second, I thought, you know, when God destroyed the earth, that was his judgment, and now that's over. Why are you talking about a whole layer of animals and fish and plants that are now dying as a result of catastrophic events?
Well, you know, when the end of the flood is described in Scripture, it doesn't say that catastrophe was over. And so, you know, the ark landed in the mountains of Ararat. Mount Ararat's a volcano, and there are other volcanoes in that area. And so we even know that in the place where the ark landed, that there's local catastrophe going on. And you come here to the western United States, and I look at what I think are post-flood sediments, and I see a lot of catastrophe in them.
So when Noah and his family and all those animals got off the ark, they didn't get off the ark and as our children's books sometimes show us, into this wonderful new Eden world where the giraffe are eating leaves off the tree and so forth. It was really an earth that was still deeply trembling.
You know, when I read the Genesis account of the flood, and Noah seems kind of hesitant to get off the ark. I mean, he sends out the raven, and I kind of picture him kind of peeking out one of the windows or something, and, you know, still see stuff going on. There's volcanic activity in the area, and he's kind of wondering, I think, is it safe to get off? And so he kind of sends some birds out to check things out for him ahead of time, doesn't he? And I see some hesitancy there. As I read Genesis.
Well, certainly, as we've talked about, we see that evidence, right? We see the evidence of the huge earthquakes, massive volcanoes, massive, you know, erosion that we see like the Grand Canyon and so forth, even after the flood. So the earth was still trembling, and I think it was Kurt Wise who was talking about that exponential curve, that today, of course, what we see is minuscule compared to those days.
I think so, yeah.